In this video, we are going to begin looking at hypothesis testing. When we're talking about hypothesis testing, we are looking at what possibly could happen. And so we're going to identify our hypothesis testing as the process by which a decision is made between two opposing hypotheses. So we're going to look at one hypothesis versus another. They're formulated so that they negate each other. They're opposites of each other. They complement each other. You're either one or the other one. Recall back when we were talking about binomials. You had to be in one group or the other group. Same thing with hypothesis testing. We're only going to have two possible outcomes here. And so when we look at this, we have two different hypotheses. The first one is called a null hypothesis. A null hypothesis is the one that we actually assume to be true to begin with. It states that the parameter, mu, sigma, sigma squared, any of those, is equal to a specific value. Is equal to. This is what we're actually testing. Is it this or is it something else? The null hypothesis gives us that starting point. It is denoted by H0, and an example of that is that the null hypothesis, H0, mu is equal to 35. So our null hypothesis, whenever we're looking at our hypothesis testing, our null hypothesis is always going to be looking like this. We are only going to concentrate on looking at the population mean, the mu. You can use the population standard deviation, the population variance, the population proportion. You can do hypothesis testing on all of those. We are only going to concentrate on the population mean, so mu. So make sure that you have null hypothesis, and then you have the symbol of whatever you are testing, okay? And again, the null hypothesis is always going to be an equal to. It's what we begin with. Now, our alternative hypothesis is the one that we want to actually test, and so it's going to state that we're differing from whatever value this is. We use the exact same number in the null hypothesis that we do the alternative hypothesis, because if we don't use the same number, then your values could actually fall between the values or something along that line. This is denoted by an H1, not an HI, an H1. And so when we look at it, we're again going to compare to whatever parameter we're looking at. And so like in this case, if we said that the null hypothesis mu is equal to 35, this one would be the alternative hypothesis mu. It's going to be compared to 35. Now it could be less than, it could be greater than, or it could be not equal to. And we're going to discuss each of these as we go through looking at how we distinguish between them. Okay, so let's look at the first one, and it is what is called a left-tailed alternative hypothesis. What this states is that it is less than the specific value. Because think about it, when we look at our normal distribution and we're looking at the left tail, that's the little bitty tail that's colored in over here. And we're always coloring in just the little bitty tail. We're not coloring in all of this over here. We're just looking at that little bitty tail. So in this particular case, our alternative hypothesis, if I'm going by our example up there, would be less than 35. Notice the direction that this arrow was pointing. that is the side that I'm going to shade as well. Less than, we're going less than over here. The second possibility is what we call a right-tailed test. And you can already guess that a right-tailed test is greater than the specific value. So when we're looking at it, our alternative hypothesis, mu, is greater than 35. Notice which direction that arrow is pointing. And so when I shade, I'm going to shade this little bitty portion over here. Again, I'm only shading that tail is what we're wanting to look at. Now, our third possible alternative hypothesis is what we call a two-tailed. In the two-tailed, what we're saying is we don't know if it's less than, if it's greater than. We're just saying that it is not equal to that value. So this alternative hypothesis is going to be mu is not equal to 35. The two-tailed becomes a little bit more complicated when we actually calculate the values and everything. Also, when we draw it, we want to shade in both little bitty tails. The two-tailed test actually is very similar to our confidence intervals. We're looking at the middle and each side has an equal value shaded. So recall when we were looking at the confidence intervals, we had a thing that looked like z alpha divided by 2. Or we had the t alpha divided by 2. That alpha is what we also call our significance level, which we'll discuss again later on. But this alpha divided by 2, it's because we are looking at two different tails. Okay? So I want you to go through and identify. Let's look at a couple of examples first. So the Blue Book value of a used 3-year-old Chevy Corvette Z06 is $56,130. Grant wonders if the mean price of a used 3-year-old Chevy Corvette in the Miami metropolitan area is different from $56,130. State the appropriate null and alternative hypotheses. So we're going to state the null and alternative hypotheses. So here's our null, here's our alternative. We're talking about the mean price, okay? And then we want it different from $56,130. So we're going to do $56,130 in both hypotheses. I know that my null hypothesis is going to say equal to. Now on this one, it says different from. Does different indicate greater than, less than, or not equal to? A different actually signifies a not equal to. So whenever we're looking at these up here, left-tailed is going to be less than, at most, fewer than. These are some of the key phrases that will signify a left-tailed test. Some that we'll consider, or a right-tailed test, of course, is greater than, more than, at least. Okay? The different ideas for a two-tailed test, of course, not equal to, different from, and let me go back and redo that one. So if it has different, differs, not equal to, these are the things that are going to signal that we're looking at a two-tailed test. So that's why that since this is different from, we're looking at a two-tailed test. Now let's look at one more example. Federal law requires that a jar of peanut butter is labeled as containing 32 ounces, must contain at least 32 ounces. A consumer advocate feels that a certain peanut butter manufacturer is shorting customers by underfilling jars. State the appropriate null and alternative hypotheses. Okay, so we're looking at the null hypothesis, that mu is equal to. We're looking at the alternative hypothesis, mu. How much is supposed to be in the jar of peanut butter? 32 ounces. Okay, so 32 ounces. So we're going to have that on both the null and the alternative hypotheses. Now, we have to be careful because this right here says that it must contain at least 32 ounces. But this advocate thinks that they are shorting and underfilling jars. So here's the thing, is federal law requires it to be 32 ounces or more. If it's more than 32 ounces, is the customer going to be upset? No. If a jar of peanut butter shows on the label 32 ounces and there are 32.3 ounces, the consumer is not going to be upset. But if there is only 31.5 ounces, the consumer is going to be upset. So we want to check to see if they are shorting, underfilling, if it is less than 32 ounces. So you have to look at it as, when is it going to be upsetting to the customer, to the manufacturer, and things of that nature. So I'd like for you to try practice setting up the hypotheses, and then let me know if you have any questions.